Okay.
Yeah.
Very good morning and afternoon to everybody, depending on where you guys are. Firstly, thank you for joining today's webinar, which is going to be on cloud supply chain security and zero trust approach. Just a few things before the webinar. As you guys know, the webinar is going to be for 45 minutes. In the end, 15 minutes, we will have a Q&A session where if you guys have any questions pertaining to today's webinar, those will be answered. If you can see, there's a Q&A box on your screen, so you can put your questions there and we will be answering those questions in the end 15 minutes. Also, before we begin with the Q&A, we will be running a quick poll, just 3 questions. It'll be great if everybody can quickly answer those polls towards the end of this webinar, and then we will move on with the Q&A. And yeah, once again, thanks a lot. I'll be handing over to Mr. Ashwin, who will lead today's webinar.
Thank you, everybody. I hope you can see my presentation. And thank you, Eva, for the introduction. And let me start with the presentation right away. We have a very interesting topic today, which is cloud supply chain and zero trust, which is one of the new hot topics these days. And we decided to do a webinar specifically on this so that we clear the air on some of the aspects of what it means and what needs to be done to take care of the cloud supply chain security, which is a new subject for many of us. So this is our agenda for today. We are going to do an introduction about us and what is cloud supply chain security, what does zero trust security mean, what does containerization mean, what is Docker and Kubernetes, and how in the last how SCDA can help in this space. So I will start with a quick introduction with a video of ours. So you saw the video quickly, and again, I'm going to introduce again. So we are a Denver, Colorado-based CPA firm focusing on cloud data security and privacy. We have an associate office in Mumbai, so we operate from 2 locations, Mumbai and Denver, Colorado. We are listed with PCAOB as auditors. We are a CPA firm. We also listed with Cloud Security Alliance as auditors for the STAR program. We also a certification body focusing on data security and privacy, ISO, IEC audits. Few companies worldwide can provide both SOC 2 and ISO under one brand. I believe there are about 10, 12 or so. We are one of them. In India, we also listed with the CERT-In, which is the Government of India body as auditors. That's my background. Many of you know me. We are in the same space of cybersecurity, data security. And many of the people who joined here are some of them are friends, some are colleagues, some are clients, etc. So for those who don't know me, I am in this industry for about 20 years, being a cybersecurity, information security auditor. I'm a CPA and MBA with global cybersecurity certifications such as CITP, CISSP, CISA, CISM, ISO 27000 lead auditor, and cloud security, of course, CCSK. As you know. So we focus since last 7 years, rather, since 2015, since I did my CCSK, we have been focusing on cloud security audits. We have been auditing the Fortune 100 companies as well as SMB customers worldwide. For cloud security, we have audited many SaaS applications, more than 200-300 audits that we do. And we cover the SOC reporting, we cover the ISO, and we also cover the cloud security assessments, etc. in the cloud space. So starting with the cloud supply chain issue, let us look back at where all the whole um, awakening happened in this space, right? So the Log4j vulnerability in SolarWinds was the wake-up call in this industry. Log4j is a remote code execution vulnerability that was exploited. And if you see the image here, right, it is the vulnerability that was exploited on the Axis. Log4j is a part of a Java Apache library, and the attackers, right, logged in and uh, used the remote code execution to target the server and gained access to it, right? That's how the Log4j works apparently, right? So again, it said it's a open source Java library in Apache. It's a public facing client server web applications. Ubiquitous data logging was the issue. And there were several flavors of the Log4j vulnerability. And even till date, there are almost 9,646 confirmed attack attempts on Log4j, right? And it's an open source issue, and we will focus more on open source software and open source technologies during our entire discussion today, because that's one of the key focus areas concerning cloud supply chain. Now, one of the major attacks, and it's a major news item that was in 2020, the SolarWinds supply chain attack, right? So attackers use this Log4j vulnerability to get into the systems, and many companies, 18,000 computers were impacted, many of them big names like Microsoft, Intel, including the US government, Homeland Security were impacted with this vulnerability, right? So I'm not going into the deep dive of what happened and how it happened, and we're not analyzing the attack surface and what they did and how did it. But the idea here is that we want to convey, or I would like to convey that or rather the industry wants to convey that these open source software also needs to be taken care. We are building cloud systems, we are doing cloud deliverables, cloud applications, etc. Right? We cannot just say because it's open source and we leave it and we do not touch it because it's open source and it's because of Apache and we got this download image, and so we need not to look at the security issues for that. No, that's not the thought process now after the supply chain attack of SolarWinds, right? So this is an awakening. It needs to be a paradigm shift in our thinking of what we need to do to look at the cloud supply chain security. And this incident, right, has awakened the industry to look at the entire end-to-end what do you call software, including open source software, to look at the security issues um, at the end-to-end process chain, right? So what is cloud supply chain security? It is a supply chain management which focuses on risk management of external suppliers, vendors, and of course the end-to-end process per se. So as I just said, so traditionally open source software was not being looked at in terms of security. We should just download the images, we should download the binaries, the libraries, right, without validating whether they have vulnerabilities or not, and build applications on it, right? Traditionally, the security was being done on the IDS, IPS, firewall, and the processes. We did not look at the open source systems that even those would have vulnerabilities, and even those needs to be tested and validated before we build an application on it. So that is the concept which we are going to talk throughout the day, or throughout this session rather, and that's what it means. So the impact was so large, right, that it has awakened, and industry has now looked at, yes, no, we need to look at the end-to-end supply chain and cover those aspects which have been missing as part of the security audits or security assessments internally and externally that has been going on for the last so many years or several years. Of course, the supply chain security also has challenges, that is data protection, data localization, data visibility, data governance, fraud detection, and third-party risks, right, which will be covered in today's discussion. An important aspect towards this is taking a zero trust security approach, which we'll also see what zero trust means, right? So zero trust, in short, means do not trust anybody, trust but verify, right? We have heard this concept throughout our life cycle in the cyber security journey, right? And it's not a new concept, but we have been trusting somebody, like some of the software, some of the open source systems, or some of the images, right? And now the thought process for at the industries, do not trust anybody, right? No part of computer, no part of networking, nothing. You earlier we should have trust zones, right? There's no trust zones. Every node needs to be validated, every connection needs to be validated, right? And every user has to be validated. Every device, every access point, every IP address, every application, every API, every user, you verify, you validate them, and then provide the access as need be. Right? Of course, we have other controls such as RBAC and others, which we are going to discuss as part of this session today. So just to distinguish, right, traditionally we have a, perimeter defense zone where we have one implicit trust zone, right? Say maybe we used to have a firewall, right? And within the firewall, if we have a LAN, right, everybody else in the LAN is a trusted zone, and everybody outside the firewall is on a non-trust zone. So the concept in zero trust security is something different. We do not trust anybody. We do not trust our colleague. We do not trust our boss. We do not trust our supplier. We do not trust anybody. So unless we validated them, right? They may be posing as somebody, right? So do not trust anybody on the face of it. Validate it. If you feel yes, they are right, that is what they authenticated. This is a person, he's saying what he is supposed to be saying and doing the same thing, then only you provide him the required access. Right? That is the concept of zero trust. So the zero trust is easy said and difficult done, because it is a thought process. It is a risk management perspective, and it needs a deep dive. It's a thought process. It is not a framework, right? It is a risk management approach that you need to take and incorporate in your uh, processes, in your people process and technology processes, to make sure that you adopt this as part of your entire enterprise security architecture. We have just mentioned three challenges here, but the challenges are too many. At every aspect of the 7 layers, right, we have challenges. Not only just access control, endpoint, monitoring, network, but these are some of the major issues that we are highlighting. But zero trust is easy said and difficult done again, right? But it's because it's a thought process. We need to revamp our entire processes to do a zero trust approach, specifically when it comes to risk management. I have highlighted this in my earlier webinars also, that the way we do risk management today in many of the ISO and SOC 2 certified entities needs a uh, lot of I would say improvement, right? And we need to relook at how we do risk management to look at the zero trust and of course the cloud supply chain security processes also. So when we talk of cloud and we talk of supply chain, containerization is the in thing. Everybody is talking of microservices. Everybody is talking of containerization. Let's look at what these things mean. So containerization is a form of virtualization wherein all the components of the application are packed into a single container images, data which can run in the same or shared operating system as an isolated user. The isolated container image is encapsulated within the requirements which are necessary to run the application. So basically, containerization's container is an image. You run the application as images in a container environment. And when you update an application, those images are discarded a new image is uploaded, right? So basically, it's an image. The application is delivered as an image. That's the whole idea of using containerization, so that the it is better application performance, and there are several benefits. But today we are not going to discuss those benefits. This is a security discussion, and we are going to discuss only about security issues in containerization. So what is Docker? Docker is an open source suite for developing, shipping, and running applications, which helps to reduce the delay between writing code and running in production environment. Right? It helps easy delivery of the applications, and that is the reason people use Dockers. What is Kubernetes? Kubernetes is an open source orchestration platform for managing all the automation and scaling. Right? That helps you automate the application delivery process, and that is the main use of Kubernetes. Kubernetes group contains that make up an application into logical units for easy management and discovery. So you can discover application easier, you can have easy delivery of applications and management of applications through Kubernetes. That's the idea. So why do we need to do security in Kubernetes and Dockers, right? Again, as we said, again, Dockers and Kubernetes is open source, and we do not want to trust any open source application just because it's open source or just because it is given by Apache or Docker or any of those companies which are backing those open source systems, right? Because everything is shared in a single package and as an image, it has its own limitations, it has its own security challenges, like we just said. Right? Traditionally, we used to have ingress points at the firewall, IDS, IPS, etc., which are not the same for container security. It's not the same for open source system because they are inside the system and they are in a trusted zone itself, right? They are within your firewall, they are within your application parameter, and we are trusting them. That is the issue. We cannot run an IDS, IPS like we used to do the traditional security. We need to have a different approach to look at the container security. Why? Now, if you look at these numbers, right, we have more than 450,000 servers listed for Kubernetes API servers. And out of this, 84% of those listed servers are exposed and have critical vulnerabilities. And some of the applications are running on such Kubernetes open source systems. Imagine the kind of exposure it could have when the vulnerabilities, right, can be exploited. Right. So this is the kind of a this is the kind of a environment that we are sitting on today, and we need to take care of this by putting processes, people, and technology in the place, and to do the right way to mitigate the risks of open source software and cloud supply chain security. Now, this is the graphical worldwide display of those same thing what you just saw. And 53% of them, as you see, is in the US region itself. The Docker exposures also have a lot of application exposure and vulnerabilities. If you look at the numbers, more than 16,000 servers are exposed and have vulnerabilities in the space. And this research report was provided by Palo Alto. Now let us look at some of the containerization risks. We have arranged those into these areas such as image risks, registry risks, orchestration risks, container risk, host OS and component risks, and the hardware risks. Let us see one by one. So the image risks, look since the applications are delivered as images, there would be image risks for sure, right? And these are image vulnerabilities, image configuration defects, embedded malware within those images, embedded clear text secrets, use of untrusted images. So these are the challenges for container image risks. And how do you mitigate them? Using distrustless images. Distrustless images means you it is some kind of a hardening. You only use specific, uh, only those configurations which are bare minimum required. You do not have all the libraries. You do not have the entire connectivities or the libraries builds or required. Only those which are specifically required to run that image is only taken as part of the images for the services. Avoid custom OS images, use only certified OS images, monitor lifetime span of images, visibility in all layers of images, age threshold should trigger a new certified image build, image configurations to be tested and monitored to avoid misconfigurations, using of quality gates and development lifecycle. These are some of the mitigation measures for the image risks. Now, look at registry risks. All of these images are stored in a registry, right? And to avoid those risks of registry risks as insecure connections, stale images, and insufficient authentication or authorization, we have mitigation such as using industry standard registries such as AWS ECR, implementing secure network controls. Stale images should be controlled by internal sys operation teams. Configuration of CI/CD processes. Existing automated scans should be done periodically. This is some of the mitigation measures for registry risks. And now look at the orchestrator risks. So orchestrator risks also, like Kubernetes is also an orchestrator platform. That's what we just saw, right? So some of these also may involve here. So unbounded admin access, unauthorized access, poor network traffic, collaboration of sensitivity level, orchestrated node trust. So these are some of the risks, and the countermeasures are implementing and monitoring role-based access control, RBAC, implementing MFA, multi-factor authentication, hosting VPCs and subnets, using overlay network for node level traffics, grouping container traffics as per the data sensitivity levels, hardening of orchestrated nodes. These are some of the mitigation measures. Now let's look at container risk itself, right? So vulnerabilities within the runtime of the containers, unbounded network access, insecure container runtime, application vulnerabilities, vulnerable containers. And how do you countermeasure them? Uploading updated tools for CVEs, containers to deploy across multiple hosts, OS stock and the application technology stack should be monitored using MAC controls, avoiding the default, using default profiles, using appware tools and automation and detection, using container vulnerability scanning tools, and all containers should be associated with individual identities and logged. So logging is important. Now next, host OS component risks, which are what are they? They are large attack surfaces, shared kernels, improper user access rights, host file tampering. And how do we mitigate those? By avoiding OS shells to prevent attack surfaces, building minimalistic OS components, hardening, of course, using minimal components as required, combining workloads, auditing orchestrators and logins and actions, and preventing containers mounting on sensitive directories. Now, there are also hardware risks, right? So hardware risk can be mitigated by using trusted hardware platforms, TPMs, right? That's the major countermeasures of hardware risks. And of course, having service level agreement with cloud providers, etc. So these are the risks, and we're going to see that what can be done to mitigate those risks and how SCDF as a company can help, right? So what we do as part of our audit services is cloud security and chain assessments. We're going to look at some of those things in the depth. What does cloud security and assessment means, and what do we do as part of the assessment itself? Then what is the SLSA or SALSA framework? How does it help? And then what is the ISO IEC 5230 auditing and certification platform? And of course, we have other third-party risk management tools such as traditional ISO and SOC 2 and other certifications. And why SCGL? Because we are competitively priced and we can do some remote assessments to save the cost. Because cloud is ubiquitous, it is everywhere, and we can connect to the cloud environment almost from anywhere in the globe. So it helps to do those assessments remotely, and it helps you to save the cost of your environment and the auditing process itself. Now, the supply chain in the cloud, what does it mean? What do you actually do to do a cloud security chain assessment? So you evaluate a supply chain strategy that covers your end-to-end policies, procedures to effectively mitigate the third party software creators, integrators, and distributors. So the risks with all your software platforms, creators, your in-house SDLC process, your third-party applications, your integrators, your distributors, your end-to-end supply chain from your build to the deployment to delivery process is evaluated. Not just a high-level external. Traditional security tools such as the ISO 27001 and SOC 2 do not look many times in the depth of your end-to-end software processes in terms of open source and end-to-end software delivery process in terms of application delivery. They only look at the application layer, whether access control at the application layer is correctly done or not done, whether your HR controls, whether your onboarding and offboarding processes are done or not done, right? You have incident management, you have other processes which are at the application layer, network layer, and other OSI stack layers. Many of those processes or the controls from your SDLC process to the application delivery process in terms of security are missing. So this is the missing piece of traditional security delivery, and that is covered as part of your cloud supply chain assessment. We also evaluate your compromise if your and any of the supply chain environments compromised, right? You also evaluate your prevalence of systems, software, configurations, and the ability to trace the origins of those builds and those softwares which you have developed or bought, right? To validate the integrity of and the artifacts and the entire chain that produce the end-to-end delivery process. This is what we do as part of security chain assessments. We also evaluate your source code, right? Third-party code, builds, pipelines, CI/CD process, artifacts, and the entire development processes in terms of the security posture. We will evaluate all the stages of supply chain that are performed and authenticated by a trusted party, such it can be validated cryptographically or via automated processes as applicable. You also need a software bill of materials called SBOMs, which is also known as a critical first step towards discovering what software components you use so that you correlate them with the known vulnerabilities. So you need to have a software bill of materials when you purchase or develop a software. When you purchase third-party software, so you need to have a bill of materials, what you are getting, how are you getting, all those codes, even if it's open source or whatever the codes you have developed, are they validated? Are they digitally signed? Right? What is the latest build of it? What is the latest release of it? Right? And to maintain a proper inventory of those systems to create a complete vulnerability lifecycle management for those end-to-end processes. And then you also evaluate your CI/CD systems that have both signed the application and the container images reproduced in the SBOM. So whatever you have SBOM in the software bill of materials, right? You validate is this correct and evaluate your entire CI/CD systems, right? to validate your entire end-to-end process, including your SBOM. Now your entire CI/CD process, also in terms of environment, materials, products, right, and all the supporting artifacts need to be evaluated and attested for in terms of cybersecurity and security in the application lifecycle approach. Then you also need to monitor and track the dependencies in the CI/CD supply chain process and to evaluate the proof of the assessments, reviews, and the components, including the dependencies of those. You also need to evaluate the notifications and vulnerabilities, whether those vulnerabilities were properly mitigated and all those fixes were correctly patched up or remediated before the application could have been moved as into the container or the images as the case may be. Right? So that is also as part of the entire end-to-end assessment process. Then we also do technical assessment, including running tools to look at the vulnerabilities as part of your build process or delivery process or the application process, as the case may be, the end-to-end process. Build, right, evaluate, and the production application itself. So this is what the cloud supply chain at a high level mean. I'm not saying it takes it everything, but this is the high level discussion, because also we will incorporate the zero trust security approach at every layer, network layer, access layer, multi-factor authentication layer, as we just discussed. And also we will evaluate all those risks that we just discussed at the image layer, at the registry layer, at the OS layer, at the hardware layer, and all those will be evaluated and assessed as part of your entire cloud chain assessment. This is what a cloud security chain assessment means. Now, some of the high-level best practices are in this spaces to create a security strategy. You have to do a vulnerability mitigation and pen testing across the entire life cycle. You need to also do a digitization and modernization of your application also. You need to do a data identification and of course encryption. You need to have your permission controls and data exchange and visibility. You need to have a trust, transparency, and prevalence. You need to do a third-party risk management, and also you need to do incident response planning and orchestration. So these are some of the best practices that the industry suggests, and as part of the supply chain assessments, they all will be incorporated with the zero trust approach to have a detailed supply chain assessment tool into your environment. Now, the next thing what you could also do, or anybody in the industry, a cloud CSP could do, is to have a supply chain SLSA framework assessment. Now, the SLSA framework is a framework by the Linux Foundation, built by it, right? It has an end-to-end process to improve and secure packages in the infrastructure into your entire SDLC projects, right? And it covers the entire chain and gives you an established framework, right, to establish your processes in this fashion, right, from a development to the source code to the build to the packages and to of course the delivery of the application to the consumers, right, and all your dependencies in between are covered. There are 4 levels of this assessment: the level 1, level 2, level 3, and level 4, right? Starting from the easiest level 1, right, and to the difficult one to the level 4. You could evaluate you choose the SLSA framework and adopt these best practices of the framework to enhance your cloud supply chain assessment and processes into your environment. The next option for you, anybody in this industry, is also to adopt the ISO IEC 5230 2020 auditing and certification standard. So this standard, right, was new. It's a new standard that specifies the key requirements for quality open source licenses compliance program, right? In order to provide a benchmark that builds trust between organizations exchanging software solutions comprised of open source software, right? So the ISO provides you a framework to validate, comply, and to build a process of how to evaluate, validate your open source softwares, and to have a established ISO process towards it. We just don't take a, say, maybe a Apache system, and just because it's open source, we trust it blindly and deploy it in a production environment. That is not what we need to do going forward. I do agree that industry has been doing it in the past. We have been doing it, and that is the reason of the SolarWinds and the supply chain Log4 vulnerability. Just one example. That could be multiple. There are even more, but I just took one example to show how it impacted the entire government and the largest of the organizations. So the downside of this is if we do not do this, there could be more impacts. And with cloud computing growing higher and higher, right, to millions and billions of dollars, and we see that all or majority of the organizations today have a cloud strategy. Everybody is moving towards public cloud, private cloud, SaaS applications, cloud CSPs in terms of SaaS and infrastructure. And, and containerization is the way forward to have faster application delivery. And if we do not take care of the entire cloud supply chain security today, we're going to have more and more data breaches, which will impact our compliances to data security and privacy, compliance requirements such as GDPR, CCPA, and so on. So the traditional tools, right, like SOC 2, ISO 27001, do not take care of the cloud supply chain security at an end-to-end system. And hence, we need a paradigm shift in the way we are looking at to, to look at the end-to-end cloud security space today. This is a gap which SEDR as an organization, which has been trusted by Fortune 100 companies and SMBs taken together and having an experience of 7+ years full time into cloud security, we are in a very good position to deliver such assessment services to all our clients and old clients as well as prospective clients. Besides the cloud supply chain assessments, we also do the traditional cloud services assurance programs such as the cloud SOC 2 reports, SOC 1, SOC 2, SOC for cloud security with the C5, either the C5, which is the German standard, or the Cloud Security Alliance's CSA Star program for level 2 and level 1.5 pilot, which we have also been doing for some of the organizations. And we also do the traditional ISO 27001, 27718, or the 17 for cloud, and the 27701 for privacy certifications, and so on. So we cover most of the data security and privacy security certifications in terms of SOC 2 and ISO. Again, as we said, so very few companies, about 10, 12 of them, are globally there to provide a SOC 2 and ISO under one brand. And SCGR is happy to say that we are one of those few companies which can give it under one brand, and making use of the cloud supply chain assessment services would take you to a one-step level higher in the cyberspace. And we urge you to take advantage of these services that we can provide to you. And again, this is a disclaimer that whatever we have said is general in nature. It was not specifically designed or addressed to any specific entity or any specific company into consideration, and it should not be taken as applicability to your environment or to your entity. And this is a disclaimer. If case you need any specific advice or services which SED can help, you can reach out to us at info@scd.com io, and we can have a one-to-one discussion to see what would suit your organization. Thank you, and I now go back to Arva to take on the questions and other polling.
Hello.
Yeah, Arva.
So, hi guys, I'm just starting the poll. It'll be great if you guys can answer the polls quickly. There are just about 3 questions, and also simultaneously you can put your questions in the Q&A box. And once this is done, we'll be answering the questions. So please just answer the polls.
Parallelly, you can also please post your questions in the Q&A session. So maybe we can look at all the questions. So if there could be even more questions in future, you can always get back to us on email, and maybe we can see if we can help you even answering your questions on email. So, so I think there's some issue in starting the polls. Maybe we can directly jump to the questions
Yeah, the Q&A.
and Q&A. Yeah, that's fine.
Okay, fine. Please post your questions in the Q&A section, guys. So Mr. Ashwin can start answering those. There's one question, so I think you can start by answering that.
Yeah, good question. Interesting. So, how quickly can we respond to zero-day events? Very good question. So of course, there have been several thoughts on zero-day events. So you could do limitation of those attack services. Uh, you could what do you say? Um, you could put some control measures to have those eliminated or access to those environments reduced, right? So that the impact of zero-day is reduced. That is one of the controls to do the zero-day. Plus, whatever the company or the OEM vendor recommends, they would always give you a recommendation to do that, right? So that is one of the best ways, or to reduce the attack surface. That is one of the best solutions to do that. Second question is the slide deck. We do share video
Yes.
recordings, and that will be shared to all those who have registered. The video recordings will also be uploaded on YouTube, and you could look at them at later time also. And I think that's the answer to the slide deck. So the PPTs in original shape are not shared because of the intellectual property. The video recordings can be shared. Now, the next question is zero trust cybersecurity. How small organization can achieve it? Excellent question. Excellent. So now zero trust, again, I said it's a mindset. It is not about how small or how large organizations should have zero trust. It is a mindset, and it is a way you do your risk assessment, and it's a way you do your controls. There are companies who are having an employee strength of just 10, 20, 30, etc. So it's not about how small or how big your environment is, right? It is about your mindset, how you want to do security and how you want to take security forward. Just two people are enough. to do an entire end-to-end controls in security area, in my opinion. Right? If you don't have a full-time person, you can always take somebody on contract. Right? So I was in one Amazon conference and I was told that the entire Airbnb platform used to get managed by just 7 people. So it's not about the team size or how big the platform is or how many people are working on it. Right? It's a mindset issue. It is how you take the security and how you have a mindset towards it.
Do we have any other questions? I would like to request people, if you guys have questions, please put them in the Q&A box so we can answer those.
Yeah, we'll wait for another 1 minute. So all the questions have been
Yes,
answered. We'll wait for another 2 minutes. If there are more questions, it's fine. Else, then we can close the session and give back some minutes to all our guests.
attendees.
So I think there are no more questions, and let us close the session. Yeah, one more question. Sorry. Is there any relationship between CCPA and zero trust security for PII? Excellent question again. Um, so I just said, I'll repeat the answer. What I just said, zero trust is a mindset. It is an approach for doing risk management. You do not trust anybody at every point of time. Now, how does that apply for privacy or CCP or any kind of a privacy compliance? I would say GDPR or whatever. Now, when you do a privacy risk assessment, also, right, you need to do a data flow analysis or data flow architecture. You need to look at end to end where and how your data is flowing and what are your compliance. And if you're an application owner, you would look at how the PII data is coming from an application and going up to your archival or destruction and the entire data lifecycle management. Now, if you apply zero trust to the entire privacy impact assessment that you have done or the data privacy impact assessment, you could apply the zero trust principles in the entire risk management lifecycle for privacy. And the data is flowing either from an application to your databases, or from your databases to your storage, or from storage to your temporary storage, your flat files, and across all the layers in the OSI chain, right? So you can apply zero trust for every compliance mandate and every environment or everything where what you're doing your risk management for. Right? It's a mindset, as I told you again and again. It's a way that you do not trust anybody. You verify and you provide access only after you have validated that person. That is a mindset, including within the network, within the databases, within everything also. There is no trusted zone per se. You're going to verify and then give access to every node, every server, every application, every API, every device, and so on, every IoT device, and so on. Right? That would apply to every compliance mandate, not just CCPA or GDPR or PII or anything, everything and anything. It's a mindset. And if you apply this, trust me, you will be much better off in terms of the compliance requirements. You will save much on your what do you say, in case you have a data breach, fines and penalties and everything will be much better off. You'll be much better off. That's all I have to say. And if there are no more questions, I think we can close it for the day. I thank everybody for coming over here and spending their valuable time. And I hope this was fruitful for you. And I'll close this call, and the recording of this will be shared to all of you. Thank you, everybody. Thank you for joining this call. Thank you once again.
Thank you, everybody.
Thanks.